I'm developing a game about exploration and discovery in a procedurally generated high fantasy world. You explore, discover things, kill monsters, level up, and maybe there's a little bit of story sprinkled in there too. I'm developing this game using my own game engine that I've been working on for quite a few years now, as part of a series of games I plan to make on this very YouTube channel. I'm focusing more on gameplay right now rather than actually making it look good, because I want to make sure that the gameplay concepts I have in place are actually solid, so don't look too closely at it right now. And speaking of prototypes, there is something that's been in need of a refactor for quite a while now. The combat system. You used to have to tap on the screen in order to target enemies. Movement was based on this sort of flag thing. It was just kind of weird. This month, with the odd vague idea of what I could do to actually improve the gameplay system, I set about implementing a bunch of different prototypes that I'd imagined up overnight. And I've pretty much changed the way that the game feels completely as a result. Let's do a quick recap of how the previous system worked. So you would tap on one region of the screen to place a flag and the player just walked over to it. That was left over from the previous gameplay system before the player even had access to the camera. On desktop you just click to place a flag and also click to target enemies, but when using a controller I didn't really have a suitable solution in order to target enemies because it just didn't really fit. This all happened as part of the original combat rework, which happened about a year ago, but it had reached the point where I think it just got a bit too old and I decided it had to go. So from the fires of the Trello board came the proposed work. Combat's going to be quite an ongoing thing, so what I'm doing is I'm collecting the work involved in actually completing the combat work in passes in the Trello tickets. So the idea for this is that I'd have a second and third and fourth pass, and that way I'll be able to come back to the jobs with fresh eyes in between, because I don't intend that I'm going to get all of this done at once. Here is the batch of work that was proposed as part of the first batch of Trello work. Probably the biggest proposed gameplay change was the idea that moving the player and also moving the camera now became the same thing. When you, the player, press on the screen, the player automatically moves forward, and also when you move your finger around the screen, you begin to tilt the camera towards the left and the right. Things like moving the finger up and down on the screen like this also affects how the camera gets positioned, but you essentially have full range of movement of the camera as well as the player. So this means that you're always on the move and you're always heading somewhere. As this is primarily a game designed around mobile, merging two input systems into one single thing is a massive benefit, because really you want to declutter things into the simplest possible systems you can. Secondly, this also helps quite significantly to build upon the game's 3 words, which are quick, flashy, lots. So it's a quick word, with the essential idea being that the player is constantly moving around as well as adjusting the camera. So gameplay becomes quite fast paced and you're sort of always on your toes. So actually when it came time to implement this, it wasn't really that difficult, as it mostly built on top of the codebase that was already there.
Yeah, do you know, that's much better.
Although one thing I did add was a slight cooldown, so the player would move for a few frames after the finger was lifted. This was really just there as a way to keep the fluidity of the player moving around while the player still adjusted their finger. So next, the player no longer attacks a single enemy which is targeted. Instead, I've replaced this with the idea of this sort of attack radius that comes out from the player from their center, with the idea being that the player would begin attacking as soon as they had even one enemy within their radius. Now ultimately this system means that attack is now based on that single principle, which is movement. The player might want to strategically position themselves according to how they want to actually attack. To actually implement this, I use my collision world system, which I wrote as part of a previous video. This uses a strictly 2D collision world to deliver you events about which collision points are intersecting. Actually setting the system up wasn't too difficult. The really difficult bit came when I was trying to figure out why it was so buggy. I ended up building this modular print-to-screen system because I wasn't able to just debug it in the console alone.
So one of the things that this debugging interface has shown me is that if I have a few enemies in the radius and then destroy them using special attacks, you see the number doesn't actually go down. So that's a problem.
It took me pretty much an entire day to figure out what the cause of the problem was, and the cause was pretty gross. It was just missing a few checks for destroyed collision points. That was it. So an entire day wasted due to a lack of a few if statements. Welcome to programming, everyone. But with these improvements came fixes for a few other collision issues I've been having for a while. For instance, enemies not attacking the player if they ultimately spawn too close to the player. Actually getting the attacking in place with that fix wasn't too bad, the player just had to check their radius. One thing I did want to get sorted with this radius system was an actual rendered depiction of it, so the player knew what they were actually going to attack. My plan to do this originally was to use decals, which is a sort of rendering technique where you project the texture down into the scene. One of the problems I had with this was that it had a massive effect on the frame rate, as in it dropped it massively. The thing about this is that there's quite a few different rendering techniques in order to get this sort of thing to work, and if it's going to be inefficient, which it might well be, then there's probably no point doing it. It'd be better to find a more efficient system and just go with that. Next up on the Trello job, what if you actually don't want to attack a group of enemies? There might be some enemies which are peaceful unless provoked by the player, so in that case you wouldn't really want your player character to actually start attacking them. So the solution that I came up with to solve that problem was to allow the player to draw or put away the weapons, which would allow you to also control the auto-attack state. If the weapons are put away, then the player will simply not auto-attack anything, but then if they're drawn, then the auto-attacks will start. And importantly, I've managed to find a way to tie this into the central theme of movement. When weapons are drawn, the player will move slower than they would if they were put away, which means that there's some incentives to manage between those two states. I wanted the wield state to be quite obvious, so the player visually had their weapons on their back when they weren't equipped at that point. Modifying the movement speed wasn't even that difficult. The difficult bit was getting the weapons to look correct when not equipped. Say if you had a sword and a shield, it should look a bit like this, but if you had two swords, it should look a bit like this. So then there's some code modifications that had to be done in order to make sure that the items knew what state they were in. My initial attempts to get this working didn't work at all. I ended up separating item transforms into their own object, and in that way that they could be reused between different items and also just generally decluttered, because I didn't have to think so much about everything in the item definition. The solution to get the cross-on effect when you have two swords equipped was actually to specify different equips for a left and a right hand. So that way the left and right sword would look different on the back appropriately. But the thing was, say you had the two shields, you wouldn't want them to cross on the back because that would just look a bit weird. So what you can actually do for the left hand definition is just copy what the right hand definition was. And I added all these copy functions just to make it more efficient. The thing was, it took a while for me to get this all in place and actually looking good. That was the hard bit. But after that, everything else just sort of fell into place. Actually getting the speed modifications to work was fine, and really I didn't really have to do much at all in order to get it in place. On mobile, I ended up switching what used to be the camera orientate button down the bottom to be just a one-click press to wield and unwield. The thing was that that's close to the player's thumb, so that makes it easier for you to have very quite granular control over that. I didn't want to have it up in the top corner because if you had to reach for it, then that would disincentivize you from actually toggling between the states quite often. And there's no real penalty for doing it often because I think this is an important part of the gameplay system. So that's good. Finally, in what was probably one of the most interesting gameplay systems of this month, I wanted to add a dash mechanic. Dashing would just be a short burst of movement in one specific direction. You probably know the drill at this point. Lots of other games have it. It would just give the player more fine-grained control over their movements, and in future as well, it might include some sort of combat effect. So for instance, dashing through a group of enemies might cause them a little bit of damage, that sort of thing. What I'm trying to do is break up movement around the world from just being a continuous movement pattern to being something that the player has a bit more control over. And what I was hoping was that it would just make it far more interesting. Though when it came time to implement it, it wasn't even that complicated. I added a new state to the entity logic to represent dashing, and then just gave it a bit of a cooldown before it switched back to whatever the previous state was. All I had to do then was make the player actually move.
I'm not very happy about that. Oh my god, did you see that? Oh, look at this. Woo. Nice. Oh, it crashed.
Of course, I needed to also hook the camera update code in with the dash as well. After that, I included a double tap mechanism on mobile to trigger the dash, and I was actually really pleased with how it ended up. With controllers though, it was sort of broken, but you know, we're getting there. One thing I'd like to point out is that everything I've changed in the combat system this month relates in some way to the central idea of movement, because movement and position in the world is really the backbone of how this gameplay model actually works. So just to recap, the old system looked like this, and the new system looks like this. And now, it's time for the bug fixes. One of the first things I had to do this month was get the mobile port of the game actually up and running again. It had a few problems because I just hadn't really touched it in a while. So there was just bugs all over the place. It was bugs like the aspect ratio was wrong because of the resizing changes I did before. The save system didn't really work properly. And there was also this weird issue where the on-screen keyboard kept reappearing for no reason whatsoever. Another one, there used to be this issue where you weren't able to mouse interact with any of the GUI elements in the exact top left of the screen. This had been there for quite a while, and I tried to fix it before, I think, and I just had no idea what was causing it. So what it ended up being was actually caused by the hover over text of when you hover the mouse over an enemy, it would give you their name. Well, what I actually did there was I created a little window that would move around depending on where the player actually clicked the mouse, and then that would give you that relevant information. The problem was that if you didn't actually hover over an enemy, then it would stay in the exact top left of the screen. And I'd set it up in a way where you couldn't see it, but it also just consumed all the user interface elements, which was really, really, really convenient. Thank you so much, GUI user interface, for doing that. I say that, but it's completely my fault. I actually solved this by adding this nice GUI information print thing to the developer console. That was a really good idea. I probably should have put that in there earlier. But that was what allowed me to figure out that it was actually that window element that was causing the problem. Another one now, I fixed an issue that had been there for quite a while when the player encountered a region that didn't actually properly have a mesh set up for it. Now this would happen if there was no actual voxels in the region itself. So say it was just a big one in the ocean. That would just mean that the mesh came back as null because it didn't create itself because it had no actual things to put into it. But the system didn't properly deal with that, so it just crashed. In the engine now, I fixed an assert error that was often occurring when you tried to shut down the animation manager. The reason for this was that when the animation manager shuts itself down, it would release a bunch of shared pointers it hold for animation definitions, which just told you where all the sequences and keyframes lived. But the problem was that each of these definitions in their destructors would then go back to the animation manager to say, hey, I've been destructed, because that is part of the normal life cycle. But if you're doing it in actual engine shutdown, then the animation manager would go, I don't really exist, and the whole thing would explode. As well as that, there was just lots of generic code improvements to the repositories. One other thing I'll mention actually was that I managed to find an issue with the Ogre 3D dependency repository thing. So essentially that in a newer version of GCC, you're expected to explicitly declare some include statement, whereas you didn't have to in the old version. And that meant that when you were building with the newer version, it would just completely blow up. Engine builds are still failing for some other dependency related issues, but I'll fix it later. Don't look at it. Don't look at it. Don't. Stop. For other improvements now, I've got a proper testing world. Oh my god. Realistically, I've wanted and probably needed something like this for a little while, because of course, if you want to test something unrelated to the world or anything like that, you don't want to have to wait for the procedural generation to actually take place because it just slows you down. What I've actually got is a system where you can assign this script that the testing world tries to run on startup, but that script is also included in the git ignore. So I can include all sorts of deplorable developer workarounds in this script without any fear of it getting actually committed, which is great. Aside from the new tests that I added, I also added some other developer flags. So there's one for player ghost mode, which just means the player is created without any of its collision circle things, so it doesn't get involved in combat. And actually, I've already started thinking about what the next month's batch of work is going to be. The thing is that now some of the gameplay is getting to be a bit smoother. I want to start thinking about actually filling the world with interesting things for the player to find. However, at this point, I'm starting to run up against the inefficiency of the world generation algorithms I've already got in place. It's implemented entirely in a scripting language and also runs only on the main thread. I've sort of been thinking about what to do on that, and after actually a few months thinking, I've decided that I think what I'm going to have to do is add some method to add custom native code to the engine and move this entire world gen implementation over to C++. The thing is that a 400 by 400 world isn't actually that big, and it's not really what I want for gameplay either. So at some point I'd have to increase it, and assuming that I might add more complexities to the world gen later as the gameplay develops, it's only going to get slower. And I'm very concerned that when I start to think more about mobile or older computers and just generic support, that sort of thing, it's just going to start to show its age very quickly. And another big part of the benefit of doing it this way is that while shifting off to C++, I'll also get access to C++'s entire threading library, which will allow me to shift this logic away from the main thread for good. I've already started kind of drilling a few of the ideas out into this ticket, so the plan is just to mature it a bit more once I've done this video and then get cracking and see how much I can improve the world gen algorithm. I'm also planning to look into character customization because I want to do some rework to the voxelizer as well. And also it's not just the map gen that I plan to farm off to C++. There's also the voxelizer, the terrain voxelizer, and the map generation thing that generates the mini map in the corner is also done on the main thread in a blocking way, so there's always a bit of a stutter when you go into a new region. This is even worse if you're in a bigger world. So it'll be great to have that off in C++ in a proper multi-threaded paradigm. I love it. Can't wait for it. Please feel free to subscribe if you really want to, and I guess I'll see you some other time. I can't turn that back one off.